Hello my shimmering stars. Today I, Shaurya Grover, welcome you all to this amazing platform of PW English. So students, I welcome you all to your Nexus Batch. And ma'am, what are we going to do today? So today students, we are going to do the next session for our chapter Chemical Bonding. And in this particular session students, we are going to draw so many structures. Now ma'am, structures of what? Structures of overlapping students. Yes, you heard it right students, we are going to do the overlapping part 2 and then we are going to start with some portion of hybridization. Yes, I hope so the previous segment, the previous lecture was helpful for you. Now my request is to take a copy, to take a pencil or a pen and just draw the structures, understand the structures with the help of me, right? So what you have to do is students, whensoever I will be giving you, let us say I will give you that kindly draw, the structure, the overlapping structure for the case where dxy is overlapping with px orbital on the z-axis. So I will be providing you 2 minutes. What you have to do is at that spot of time you have to pause your video, draw the structure first and then match your answer. So if you are going through, just like you are writing the notes, creating the notes and not practicing by your own, so let me tell you, you are lacking somewhere, right? So it's better to pause the video, try the question or the, part which we are doing by your own first and then match with me. That will help you to know your mistakes, or that may also help you to know that through which method you are doing and through which method I am doing, so that you can rectify from that as well. Yes students, now as I have already told you, we are going to start with your lecture number 4th for your chapter, that is chemical bonding ma'am. Yes everyone, chemical bonding. So let us proceed. What are the today's target or what is today's topic we are going to complete? We are going to proceed with overlapping part 2. Yes, and after that students, we are going to do some topic of hybridization as well. Hybridization as well. Clear everyone? So these are the segments that we are going to cover. Okay. So let us proceed with the very first part. Oh, so your friends came over here, barium and calcium. So basically calcium as usual says, hello my shimmering stars, have you revised yesterday's session? And barium over here says that, hi friends, be ready for overlapping. That's great students. So now, the very first part about overlapping that we were doing in the previous class, we got to know that there are two kinds of overlapping. One is axial overlapping, another one is sideways overlapping. I am going to give you a quick review of what we have already done in the class so that we can now proceed to the next part of it. Yes, so here I am telling you about overlapping ones. See, if I will discuss in detail about overlapping topic, we have already done about axial overlapping that leads to the formation of axial overlapping that leads to the formation of which bond formation? Sigma bond formation. Yes everyone. And if I'll talk about the next kind of overlapping, that was sideways overlapping. That was sideways overlapping and it basically concludes pi bond formation. Which bond formation ma'am? Pi bond formation. Yes everybody. Now today I am going to show you one more type of overlapping in which we obtain basically which bond? A delta bond. Which bond students? A delta bond. How is delta bond observed? Where it is observed? In which kind of orbitals do it is exhibited? So it is seen in the case of d orbitals. In which case? In case of d orbitals. And among d orbitals also students, we very well know that there are various kinds of d orbitals such as dxy, dyz, dxz, dx square y square and dz square. Among all of these d orbital students, let me tell you that delta bond formation do not takes place in dz square. Delta bond formation do not takes place over here. In this case, delta bond formation won't take place. Over here, you can clearly observe that there are two kinds of overlapping that exist. One is axial, another one is sideways, right? Other than that, we have one more bond formation. For example, in axial, we have sigma bond. In sideways, we have pi bond. So, we have one more bond, that is delta bond, which is only and only seen in the case of, we are talking about sp and d only, right? So, in d orbitals, it is seen, but in d z square does not exhibit that kind of bond formation. Over here, right? Now students, let us once discuss, the shapes of all the d orbitals, so that when I am going to start with the overlapping part, you will get to know. Then I will let you know how is delta bond created. So they basically, we have already done sigma bond formation, pi bond formation, right? Now I am going to start with the delta bond formation. I guess everybody has written this over here. Now I am going to write the shapes of orbitals, which we have already discussed, but yes, before doing that, let me show here the structure once for all. See, shapes of d orbitals, let us talk about dxy. If it is your before that, let me tell you, these are two kinds of d orbitals. One are the axial ones and one are the non-axial ones. Axial ones are the one in which lobes lie on the axis, such as dx square y square and dz square, while non-axial ones are the ones in which the lobes don't lie on the axis, but yes, it lies in between the axes. So over here it is dxy, dyz, dxz. So one by one I am going to draw them over here, students. Let us first see dxy. If I am talking about dxy, it is non-axial. The lobes will lie in between the axes. If it is x-axis, it is y-axis. So lobes are going to lie like this. Yes, the lobes lie in between the axes. The lobes lie in between the axes. Clear everybody? Now comes the next one. dyz. Let us consider this is your y-axis, now this is your z-axis. Again, the lobes will lie in between the axes. Now let us talk the third case, dxz. If it is your x-axis, let us consider this as your z-axis. The lobes lie in between the axis. This was about the non-axial ones. Now let us talk about the axial ones, that is dx square y square. Here lobes will lie on the axis. If it is x-axis, this is y-axis, lobes will lie on the axis. Lobes lie on the axis. Last case of this is dz square. This is your z-axis, one lobe is like this and other creates a ring-like structure over here, right? Other creates a ring-like structure. So this is the structure for dz square. Everybody, you can correlate with this part. Now students, we are going to start the formation of delta bond, how delta bond is formed. Students, here I am going to take some cases in which we will get to know about the formation of delta bond. So here I am taking a case of dxy and dxy basically on the x-axis. Let us take this case. This is your x-axis. No, let us take not on x-axis. Let us take this on z-axis. Here, if it is your z-axis, let us consider this as your x-axis, this as your y-axis, this as your x-axis, this as your y-axis. Now, what actually is dxy when the lobes lie in between the axes, students? So here lobes are lying in between the axes. Here the lobes are lying in between the axes. So everybody, if you want to draw, okay, Sorry for writing it again over here. I'll first give you the simple case, then only you'll get to know. So here I am taking dx square y square on z axis. I'm taking a simple case so that you won't get confused once, because if I'll directly move on to the complex one, you will feel difficult. So dx square y square, x axis, y axis, right? Lobes lie on the axis. Dx square y square. Now how is delta bond formation taking place over here? See, over here, this x1 will do bonding with this like this, and this will connect with this one. Similarly, the x1 with the x1, sorry, what is happening? Yeah, the x1 with the x1 and the y1 with the y1. So where 4 lobes are involved in the bonding process, this leads to the formation of which kind of a bond? A delta bond. A delta bond. See, remember, here this axis is not present in between all of these, so that's why this formation occurs. This is a trick you can say. For example, if formation occurs like this is basically your which kind of overlapping, that is axial. If bond formation is occurring like this, from the top, from the bottom, from 2 sides, this is sideways, that is pi bond formation. But if it is occurring like this, getting my point? For example, this is my hand, this is my first hand. Over here from the top, from this side as well, from this side as well, from bottom side as well, from bottom side as well. Like this, in which axes are not same. Here see, it was same axis, bonding take place. Same axis, not same axis, delta bond formation. Everybody take this case first of all, then I will be taking various cases and I'll let you know the formation. Done? Okay, now students, we are going to take case by case and we are going to draw it. First is dx square y square on the x axis. Now here I have written internuclear axis. This is your internuclear axis, everybody. Right? So here first of all, we will be writing this is your internuclear axis, which is your x axis as per the question. Now see. See, let us consider this is your y-axis, y-axis. First, let us draw dx square, y square. If this is your x-axis, this is your y-axis. Lobes will be made on the axis because dx square, y square is an axial one, right? So, it is lobes are created on the axis. Dx square, y square, initial one. No, so now, when we are bringing them all together, what will happen? Ma'am, very simple. Ma'am, it's very, very simple. See, this is initial one. This is the second one. See, when these lobes will interact with each other, what will happen? Which kind of a bond is created? Which kind of a bond? You can clearly see it is coming like this. Only 2 lobes are involved over here. You can clearly see, and on the same axis, not the sideways, not from the top, not from the bottom. It is coming like this. So it is basically the formation of which kind of a bond, ma'am? Sigma bond. So which kind of a bond is created over here, ma'am? Sigma bond. Here it is axial overlapping. Here it is axial overlapping. Very simple part. Now let us take another case. Let us take another case. Let us consider this now as your what axis? Here what is the internuclear axis provided? Ma'am, y axis. And again you have to take dx square, y square. Again you have to take that case. So let us consider this is your x axis. Now you have to draw it. Dx square, y square again will be on the axis itself. Similarly, the another dx square, y square will be again on the axis itself. Let us consider this is your x axis, x axis. This because you have taken internuclear axis as a y1. Now combine them, what will happen? These 2 lobes will connect with each other. Right? So over here you can clearly see it is your x-axis, x-axis. Over here you can clearly see this is your overlapping region. Which kind of a bond formation occurs over here, ma'am? Again, sigma bond formation is taking place. Sigma bond formation is taking place. That means it is again, ma'am, axial overlapping. overlapping. Again what? Again it is axial overlapping. Clear? Let us take this case. I'll take this case on the next slide. Dx square y square on z axis. Next slide I am writing. Now we are going to take on z axis, which I guess we have already taken. This one, dx square y square on the z axis. So you can see the delta bond being formed over here, right? I'll write on the previous slide, not in the next one. Let us write on the previous slide. We have already taken this case. Shall I move on to the next page if everybody has written? Students, please write it down. Everybody, please write it down so that I can now move on to the next slide. Now we will be taking some more examples. Now comes the next case. See, here it is written dyz. Either you have to take y-axis or the z-axis. Now that means you have to take twice of dyz. Overlapping of dyz, and either take y-axis or z-axis. See, initially I am taking this as your y-axis, okay. So now dyz, let us consider this is your z-axis, this is your z-axis. Now understand, what is dyz when lobes are present in between the axis? So now they will be present in between, not on the axis, in between the axis. Now what will happen when they will combine? This upper one will combine with this upper one, and this one. Why? Because the axis is same. Because it is basically dyz. It is basically dyz. It contains y-axis already in it. The axis is same, right? So here what will happen? Which kind of bond formation will take place? See over here. When they will, ma'am, come together, see, which kind of bond formation is occurring? Here are the two overlapping regions. That means, ma'am, over here pi bond formation takes place. Clear, everybody? Same will occur on the z-axis. If you are taking z over here, you are drawing dyz only. That means over here again two regions are the one where overlapping occurs. So this is again pi bond formation. Let us take another case. Now we have dyz on the x-axis. Now x's are different. See, here lobes will be present in between y and z, but this is x-axis. So it is a different scenario. Let us see this case now. Let us consider this as your x-axis. Let us consider this is your y orbital, this is your z orbital. This is your y orbital, this is your z orbital. Now see, they are present in between the axes. So yes, students, which kind of bond formation is taking place over here? See, very simple, ma'am. Very simple, ma'am. This will combine with this one, and this will combine with this one. This will combine with this one, and this will combine with this one. Very simple, ma'am. If it is positive, positive, negative, negative. Positive, positive, negative, negative. So positive is going to combine with positive, negative with negative. Which kind of bond formation, ma'am? Here, delta bond formation takes place. Which kind of bond formation, ma'am? Delta bond formation takes place. Everybody write down so that I can take next case over here now. If you have done with this case, let us say take the next case. Now here it is dxz on either x or z. So we are to take two dxz. Let us take x-axis. Let us take this as your z-axis. Your z-axis. Now lobes will be present in between the axis. This is also dxz, this is also dxz. So axis is also same. So it will come like this. You will see what kind of bond formation is going to take place. Right? So two overlapping regions, ma'am, here pi bond formation takes place. Here pi bond formation takes place. Clear, everyone? Now everybody write down the structure for this page also so that I can now move on to the next page of mine. Done with this? That's great. That's great, everybody. Now comes the next part. Here we are going to take dxy on the y-axis. If it is y-axis, it is your x-axis. Lobe will be present in between the axis. Similarly, it is your x-axis. Lobes will be present in between the one. Now you know the answer. It's very simple. If it is your y-axis, it was x, this is dxy, another it is dxy. Again two overlapping regions, ma'am. Again pi bond formation. Again which type of bond formation, ma'am? Pi bond formation. Now see, dxy with x or y? X or y? See, we have taken dxy with y, let us take with x now. If we are taking with x, let us take here y. Again, lobes are present in between the axes. Lobes are present in between the axes. So, when you are combining them all together, this is again your x-axis. It is going to be, lobes are present like this. So, here which kind of bond formation, ma'am? Here also pi bond formation occurs. Here also pi bond formation occurs. Clear everyone? That's great. That's great. Now see students, now comes dz square with px. Dz square you very well know. Now which x's you are going to take when they have not mentioned you? When they have not told you, just over here take x-axis for once. See, this is your z-axis, so it is going to be like this. And this is your px. Right? So, here take x-axis internuclear. What you are going to get? See, here you will get so this is the overlapping region, ma'am, sigma bond formation. Sigma bond formation. This is x-axis, this was px and this was dz square. So, over here sigma bond formation. Now, this is your first homework as a question. Write in the comment section which kind of bond formation will occur when dz square is combining with py, keeping y as an axis and keeping z as an internuclear axis. Let us see what answers are you going to get for this particular stuff. Yes, everybody? So, this is first homework question, A and B part. You can write and write your answer. Now comes dx square y square with py. What kind of axis we are taking? Let us take, we will take, x-axis over here. This is your y-axis. So, lobes will be present now on the axis. And let us say this is your py. So, when it is coming close, students, this is py, right? This is dx square y square. So, when they will come close, how will the structure look alike? This is x-axis. Will there be any overlapping? No, ma'am. There will be zero overlapping. There will be zero overlapping. No overlapping over here. There will be zero overlapping, ma'am. Clear everyone? Clear? Now students, moving on to the next one, taking dxy and px. See, first of all I am taking x-axis, here I will be taking your z-axis. Clear? Now, dxy, if it is your y-axis, dxy, lobes are present in between the axes. What is px? Px is like this. This is px. This is dxy. So now when they will overlap, it is like this. When they will overlap, not possible, no structure in such a way. So again it is the case of zero overlapping. Clear everyone? That's great. Now see here, if you will take z-axis, let us consider this as your x-axis, this as your y-axis. So this is your y-axis. Now, we don't have to draw dx square y square, we will draw dxy. So, will there any bond formation occur? Just see, this is on the axis, this is not on the axis. It will be here. Will there any bond formation occur in this case? No, ma'am. Again, it is the case of what? Again, is the case of zero overlapping. Yes, students, done with this one? Or not? Just think once. you are taking dxy, you are taking py, you are taking dxy, you are taking py, which kind of bond formation will occur? Will there be any overlapping? Yes, ma'am. These two orbitals will overlap with each other. It is coming like this. Or not? Okay, just write your answer in the chat section whether it is zero overlapping or it is pi bond formation. Very easy question. Although I have already told you the answer, but yes, let's see. Will it do like this or won't it fit over here? Question number 2. Zero or pi bond. Let us see the next case now. dxy with pz on the z-axis. So this is pz on the z-axis. This is x-axis, this is y-axis. Lobes will be lied in between the axes. Any kind of bond formation, ma'am? No, ma'am. Zero overlapping. Zero overlapping over here. Zero overlapping over here. Clear, everyone? Now, students, come to the next part. That difference between sigma bond and the pi bond. We have now studied about sigma bond. We have now studied about pi bond. We have also seen the delta bond. So, what is exactly the difference between both of them if you want to know? Let me tell you. Sigma bond basically is a strong bond because that is the initial bond that takes place. First of all, sigma bond will be created, then it will be pi bond and then it will be the next pi bond. That means single bond, double bond and then triple bond, right? Sigma bond is the most strong bond and then comes the pi bond, which is the weak bond. Sigma bond is more stable than the pi bond. It is more stable, pi bond is less stable. Now always remember, the one which is more stable is less reactive because stability and reactivity are inversely proportional. So the one which is more stable will be least reactive, so it is less reactive. And this which is less stable, students, is more reactive. It is more reactive. Next part. Hybridization depends upon sigma bond. Now we are going to start with the next topic, that is hybridization. So it basically only and only depends upon sigma bond. It won't depend upon the pi bond. Always remember, hybridization does not depend upon pi bond. So if one thing, if I will tell you, in the case of organic chemistry, if you see the hybridization for the case of carbon, no, hybridization can be calculated as sigma bond plus lone pair sum. If their sum is 4, hybridization will be sp3. Sum is 3, hybridization will be sp2. Sum is 2, hybridization is sp. So it is clearly told that don't include pi bond. You know, don't count pi bond over here. Just count sigma bond and lone pair of electrons. Now what are lone pair of electrons? The one that don't participate in any bond formation. So that means hybridization only and only depends upon sigma bond, but hybridization does not depend upon the pi bond. Clear, everyone? Next comes shape of the molecule is determined by the sigma bond present in the molecule. Now shape is also determined by what? The sigma bond. But pi bond does not affect the shape of the molecule. Next part. Can independently exist, but it cannot exist independently. Okay, it always exists along with sigma bond. Okay, it cannot exist independently, but yes, sigma bond can do so. So these are the differences, students. Now we are going to start with the topic, that is hybridization. We are going to proceed with the segment of ours, that is hybridization, students. What is hybridization? The concept was introduced by Pauling students. Basically, hybridization is intermixing of the orbitals. Okay, after that which we attain, each and every orbital has same energy. See, let me ask you one thing. If you remember the Aufbau principle, right? According to Aufbau principle, we created an energy trend for which we are going to fill electron as per that n plus L rule. Yeah. So lesser the value of n plus L rule, less will be the energy. More the value, more will be the energy. Initially, in the form of increasing order, you are going to fill the electrons, right? So if I'll say 2s and 2p, do they have same energy? No, ma'am. They have different energy because they have different value of n plus L rule, right? Now coming over here, when hybridization takes place, students, over that at that spot of time, each and every orbital will exhibit same energy because we are creating first of all hybrid orbitals. And atomic orbitals are the one which have a different energy for each and every different orbitals. But yes, hybrid orbitals are created by intermixing of atomic orbitals which generate what? Same energy, the hybrid ones. So hybrid ones basically are the one in which intermixing of atomic orbitals occur. So definition is the intermixing of atomic orbitals of almost same energy and the redistribution into an equal number of identical orbitals. I will give you an example, you will get to know one by one, but let's see further. Now, the number of hybrid orbital formed is numerically equal to the number of orbitals participating in hybridization. So, let us consider if we have 2 orbitals participating in hybridization, so we will be getting 2 hybrid orbitals further. If we are having 3 atomic orbitals participating in hybridization, we will be attaining 3 hybrid orbitals, right? So, this is the way how it occurs. Next part, the orbitals involved in hybridization have different shapes but almost same energy. Very important part, they have different shape but they have same energy, students. The next part is the orbitals formed in hybridization processes are called hybrid orbitals, which I have already told you, right? So, the next portion over here, students, is to let's discuss about an example of hybridization once. See, let's talk about the case of carbon. Let's take a case of CH4 molecule. See, in this case, we know carbon has atomic number 6. So, the hybridization is 1s2, 2s2, 2p2. 2 plus 2, 4, 4 plus 2 is 6, right? So, now see students, in this orbital if I will talk about 2s2 we have 2 electrons, in 2p2 we have how many electrons? 2. Now, how many hydrogen have to come in show bonding? 4 hydrogen, but over here only we have 2 unpaired electrons. That means only 2 hydrogen can come to bond. So, no. What are we going to do? We are going to create a state in which we have 4 atomic orbitals for 4 hydrogen atoms to create a bond. So, what will happen? This is basically your ground state. Now, what we are going to do? We are going to move on to excited state in which 1 electron from the s orbital will move on to the p orbital. So, now it is 1, 1, 2 and 3. How many unpaired electron? 4. That means 4 hydrogen can come and create a bond with that. Now, when we are going to draw the structure with the help of excited state, we see that bond length value is not same. Bond length value is different, okay, but which does not determine the shape of, the structure. So, now, what we are going to do? We are going to do the hybridization. Now see, before hybridization we have 2s and 2p which have different energies. Now after hybridization there will be intermixing of these 4 orbitals. When they will intermix all together, 4 orbitals will be created. When s and p are intermixing all together, 4 orbitals are created, right? Now these hybridized orbitals have same energy, and now hybridization process has occurred. Now hydrogen will come and join and it will create which kind of a shape? A tetrahedral shape, a sp3 geometry. How I got to know that? Let us discuss them one by one. Now you know what is the need, okay? So here I am going to write number of atomic orbitals. Here I am going to write the shape, and here we will be writing the hybridization. Here is the bond angle. Now see students, let us take the very first case where we are taking 2 atomic orbitals. Now see what happens. One thing let me more tell you. Here we are intermixing s and p. S orbital is spherical, p orbital is dumbbell shape. When we intermix, we create this kind of orbital, but in actual students, it won't look like this. This is created though, but in actual, when we'll see, structure is now like this. This structure is equivalent to this structure. When we are mixing s and p together, we are obtaining this structure. Now the atomic orbitals, the hybridized orbitals that we are obtaining is 2. Number of orbital, write down number of orbital, number of hybridized orbitals over here that we are taking is 2. Now when we are taking 2 orbitals, it is first orbital, let us say second orbital, this is second orbital, first and second orbital, making again. This orbital represents that yes, this is now hybridized orbital when s and p have been combined. So now we are taking 2 of them, so this is first one, let us say this is your second one, again this small portion will go inside, right? So now this is what? Which kind of a shape? It is a linear shape, and what is the angle over here? You can clearly observe, ma'am, angle over here is 180 degree, right? It is linear shape, angle is 180 degree. What is hybridization if I'll ask you? When 2 atomic orbitals hybridize, join with each other, one will be s, one will be p. It comes out to be sum of 2, so it is sp hybridized. It is how? It is sp hybridized, right? Let us take another case. When we take 3, now when we are taking 3 basically students, just see, this is going to be your first one, this is going to be your second one, This is going to be your third one. Yes, this is going to be your third one. So this is basically, if you'll join their, join them all together, what are they forming? If you'll join them all together, they are forming creating a triangle like this. So this is basically trigonal planar, sorry, not triangular, trigonal planar. It is basically trigonal planar. What kind of hybridization in the case of 3? 1s, now 2p. How many maximum of p can occur? 3 can occur. So it is sp2 hybridized. Now bond angle, it's very simple. Bond angle is 120 degree. Bond angle is 120 degree. Everybody please write down so that now we can move on to the next part of ours. Yes, if everybody has written this so that we can move on to the next part of ours. If you want to draw the triangle, students, let's draw the triangle also. Just take from the center like this lines. Right? Now you can connect all of these lines. Let's see how we are going to connect it. So you can see it creates a triangle and it is on a simple plane. So it is trigonal planar. Clear everyone? Everybody please draw the structure. Now we shall be moving on to the next part, that is with the fourth one. When we'll take 4 together. So now in the case of 4 students, it is a kind of a tetrahedral geometry. Now in tetrahedral geometry, in actual, how does it looks like? For example, if I'll talk about carbon, one atom over here, one over here, one over here, one will be like this and one will be like this. This is in actual the tetrahedral geometry. This is in actual the tetrahedral geometry. Clear everybody? This is for 4. And what will be the hybridization, ma'am? See, for 4 it is 1s and how many p? 3p. So total sum comes out to be 1s and 3p. That means the sum comes out to be 4. It is sp3 hybridization that takes place over here. It is sp3 hybridization that takes place over here. Clear? 109.28 degree is going to be the bond angle for this particular case. Now let's talk about the fifth one. 5-1. Now see, in the case of 5-1, let us take a case of an atom A. It is bonded with 5 atoms. So this is going to be the case for the 5-1s. This is going to be the shape for the 5-1s. Now here, what is going to be the hybridization? 1s, 3p, its sum is 4, now 1d. sp3d, what is going to be the shape? sp3d, trigonal bipyramidal structure. Trigonal bipyramidal structure. Trigonal bipyramidal structure. Clear everyone? Let's take one more case where we have 6 orbitals. Now in the case of 6, let us take an atom A. This is the case of 6 atomic orbitals, 6 bonds it is forming. What will be hybridization? 1s, 3p, that means 4, 2d, that means 6, sp3d2, that means 6, sp3d2, that means 6. So it is octahedral. It is what? Octahedral geometry. Clear everyone now? This was hybridization part 1 that we have done now. Let me show you all of them all over here again. See, this was all about hybridization. Now these are the hybrid orbitals which an actual look like. So this is when you take 2 orbitals, you are going to obtain linear geometry. When you are taking 3 orbitals, you are going to obtain trigonal planar geometry. When you are going to take, 4, you are going to obtain tetrahedral geometry. When you are going to take 5, you will obtain trigonal bipyramidal geometry, right? And when you are going to take 6, you are going to obtain octahedral geometry. Yes, everybody, I guess this particular thing is clear to each and every one of you. Now, students, we are going to do some different shapes of hybridization such as seesaw, V-shape, bent shape in the next class, that is hybridization in detail. And yes, next class will include so many questions to practice. So everybody be prepared for next session as well, right? in today's session, if I'll give you a quick review what we have exactly completed. So we have exactly completed with the overlapping part. Initially I told you about the sigma bond and the pi bond formation. Then we have discussed about the delta bond, how delta bond is created. Dz square will not form delta bond. Moving on to the now shapes, this we have already done. The next part over here is formation of delta bond. Okay, here we have taken various cases such as dx square and dx square will, when react on the internuclear axis, it will give you sigma bond. Dx square x square y square dx square y square on the y axis will give you again sigma bond. See, x square y square on x and y will give you sigma bond, but on z will give you delta bond. Next part, if you will take 2 dyz on the y or z axis, you are going to obtain pi bond. But if you are going to take dyz on the 2 dyz on the x axis, you will obtain delta bond. Now, if you will take dxz on x or y, or x or z, sorry, on the same axis of them, you will obtain pi bond, but when you will take on different one, it will be delta bond. Next, if you will take 2 dxy, okay, on y axis you will obtain pi bond, okay, on x axis you will form pi bond, but on the z axis it will form the delta bond. Now dz square on the px, it will be sigma bond again. Dz square on the py, now I have given you homework, when you are taking y axis and z axis you have to answer me. The next part is when you will take dx square y square and py on the x axis, you will get 0 overlapping. Next part was the xy and px on the x axis, again 0 overlapping, but on the z axis it is question mark again, question number 2. Next is the xy and pz on the z axis, again is 0 overlapping. The xy and pz, okay. So then we studied about sigma bond, pi bond, then about hybridization, and now students, we are going to end our class today over here. We shall be meeting in the next class with hybridization part 2, and we are going to complete basically all the questions with regard to the topic we have done in 3 sessions of lecture number 1, lecture 2, lecture 3 all together in the next class. So be prepared for your question segment, everybody. Now we shall be meeting in the next class. Till then, keep smiling, keep learning. Thank you so much and have a good day, my dear students. Thank you. Sir? Sir?